All right. Well, good morning, everybody. Welcome to the Open Science Subcommittee. Uh, Apologies for having to move the date out a little bit. There were some scheduling conflicts, but glad you all could make it this morning. Um, so my name is Alex Manos. I'm with the Pinellas County's Division of Environmental Management. I'm the new co-chair of the Open Science Subcommittee. Um, just wanted to say, glad to be here. Really excited to be part of this group. Thanks to Marcus for hosting this and getting this group going. It's great to be for open science, but to have it in practice like this is uh, really great, especially when he's putting his code online, which has been a huge help, by the way. Yeah, it's great to be here and excited to be involved and part of the group going forward. Um, there's a couple of people I don't know here, so maybe if we could just do a quick introduction, go through, just name who you're with. Marcus, you want to go first?
Yep, and there are some new names in here, so that's exciting. Marcus Beck, I guess I'm the other co-chair of this subcommittee. Senior scientist, Tampa Bay SRA program.
I'll just go through the list. Jim Hagee,
I'm Jim Hagee. I'm with the EPA's Office of Research and Development. I used to be in Gulf Breeze, Florida, where I worked with Marcus. Now I'm in Narragansett, Rhode Island.
G. Blanchard,
Yeah, hi, I'm Greg Blanchard with Manatee County Natural Resources Department and am a dabbler in open science when necessary for my projects, I would say, and glad to be here.
You're
and
really quiet, Greg, FYI. We can barely hear you.
A bit distant from the microphone.
Emma Dantas,
Hi all, Emma Dantas. I'm with Pinellas County Environmental Management.
Carrie Flaherty-Wallia. Hope I pronounced that.
Work for the Tampa Bay SRA program as a restoration ecologist.
Maya Burke,
Hey all, I'm Maya Burke. I'm the Assistant Director of the Tampa Bay Estuary Program.
Megan Schrant,
Good morning. I'm Megan Stratton, marine ecologist with the National Park Service based at Everglades National Park.
Mike McManus,
McManus. I'm a spatial ecologist with the US EPA Office of Research and Development. And I used to be a stone's throw away from where Marcus works, but I'm now up in Panama City Beach.
and Mike Wheeler.
Hello, I'm Mike Wheeler. I work for Florida Fish and Wildlife Research Institute.
And I think
and then once you get there, probably have a lot more things.
Dave Carlin.
You can go for local charity. Wherever the area you're in, that's what the charities bring up. So they bring out like 5 or 6 charities in the area, and you can only go to local. So it's really, so these are all 200,000.
Okay, well, can you hear us, Dave?
Hey, we can't hear you.
Okay, well, hopefully it gets his sound fixed. Okay, so we'll move on to the OS updates and by TBEP and partners. And Marcus, take over that.
Right, so as per usual, I will give some updates, mostly just cool things that I found since we last talked. And then Jim will talk, and then I'll talk about some a more tangible product that I think might be of interest. So we've been trying our hardest to distribute the notifications about our hackathon coming up. Hopefully you've seen them through our various email lists or social media accounts. This is going down next month on the 27th. That's a Monday at the Tampa River Center. This is the first time we've done a hackathon. We will see how it goes. If it's great, we'll do it again. If it's not great, we won't do it again. But we're hoping that this will be an event where basically you show up, you're confined to a space for a certain amount of time, and you use your creative inspiration to develop something during that time. And basically, we're hoping that this will be an event where folks will come to develop a concept of an indicator reporting workflow to help us fill some of our reporting gaps that the SRA program has related to our broad objectives under the comprehensive conservation and management plan, the CCMP. The winner of the event will be invited into a contract with us if they want to for $20,000 to fully develop the workflow that they've conceptualized during the hackathon. So this isn't just for fun. There is money on the line. Hopefully that's an incentive to participate. We have more information about this on our website, all of the details that you might be interested in, really more about what this is about, how to prepare, what to bring, all the good stuff, how to register. We have 2 webinars coming up that are going to go through this in a little more detail. If you want us to literally walk through this content with you in the webinar, we could do that, and also your chance to ask questions. One of them is actually tomorrow, so if you're interested in this and you want to know more, definitely sign up for that. Yeah, so I already kind of explained what it is, but again, this is really our attempt to sort of crowdsource the idea of how we can develop reporting workflows on different Bay Health indicators. I didn't mention that we're supposed to be doing this as teams, so you can register as an individual, but you will be grouped with a team based on your skill sets or interests, or you can gather a team of your own choosing, and you can register them on behalf of your teammates. So that's the idea there. As far as what we mean by eligible indicators, so as you know, as a program, we report on many different things, whether that be water quality, fisheries, habitat trends, you name it. But there are some things that we do a not so great job in terms of reporting on status and trends and what that means for managing Bay Health. And so we've kind of developed this list of eligible indicators that we think would be ripe for developing an analysis workflow for going from data to product. And so that could be various aspects related to wildlife, whether that be birds, sea turtles, marine mammals, terrestrial turtles, amphibians, invasive species reporting, or aspects of human health and well-being, which are important to us as a program, but we don't necessarily routinely report on them and how they relate to the intersection with the Bay itself. So if you go to the webinar tomorrow, I'm going to show a list of data sets that could be used to address these different indicators. So these are mostly indicators or topics that we know we don't currently report on, but there is data available out there to work with when we talk about reporting on status and trends as an indicator of Bay Health. So that's the idea. These are things that are ripe for the picking. We hope that you would come to the webinar or the hackathon and develop a workflow around these tools. Our CCMP is linked here. You can get a sense of the different topics we care about as a program, and also see links to some of our existing reporting products, but also some things that we know we should be reporting on, but we currently aren't, just because we haven't developed the workflow. Okay, so next thing is we do have, related to reporting, the next iteration of our habitat report card is now available in a draft form if you're at the Habitat Restoration Consortium meeting last week, Carrie talked about this, but this is one of our newer reporting products where I'm not going to go through all the details here, but basically it looks at how our partners are doing regards to various restoration projects that have happened each year and reported to us, which then gets reported to the EPA. Kind of talks about what was done this year relative to the past. And then the next slide is more about long-term, the bigger picture about acreages and coverages of habitats in our watershed and how that relates to our goals and targets, both short-term and long-term. So that is out there. We're hoping to get this finalized early next year. The Water Management District should have an updated seagrass or subtidal layer that we can use to inform how we're doing with subtidal habitats, but we're not going to finalize this report card until that is available. All of these things are, of course, supported by other open source products we've created. The TBEP tools package has some routines for synthesizing those data sets if you want to use that on your own. And we have the actual data set available as a database here that we update each year with metadata, and it's archived on this link. And you can access existing products on our webpage through that link. This is just a mix of several links that I've found over the last couple of months since we last spoke of different things that I think would be of interest to this group. Different papers, different suggestions for scientific programming. This one is pretty interesting. It's a satire article that really is kind of meant to promote the use and spread of open data, basically describing all the things that you shouldn't do for making your data open. It's a pretty funny, good read. This is a link to an archive of a group that I've been following for a couple years now that they're kind of more freshwater focused and more ecology focused, but they've been doing a lot of good initiatives over the years where they have an annual summit. They also have webinars. They've actually archived all of their materials on the Open Science Foundation's webpage that is available. There's, links to talks from years past, a lot of good content there. I think Mike Meyer talked to this group. He's one of the organizers. He spoke to this group, I think, last year. But he's, kind of responsible for all this. And it's just a great resource if you just want to peruse the materials to get up to speed with what they're doing. I have a link to some R training here available through NCs, and then a funny little short lightning talk about how to name files. This was actually given at POSIT conference earlier this year. If you are familiar with POSIT, they're the group that makes R Studio and other open source products. They had their conference earlier this year, and all of the presentations are available online. And this one in particular, I thought was pretty good. Jenny Bryan, I've been following her for a while. She's got a lot of good content out there about data science that's useful. And then the last thing I wanted to show you before we get into Jim's talk is just another example of an AI tool that I found pretty useful. AI for the generative AI tools, for what it's worth. There's a lot out there now. A lot of it's garbage. A lot of it's, I think, useful. But this one in particular, if you are in the business of making shiny apps, which I know some of you on this call are, I found this one to be very useful because it is developed specifically for creating shiny apps. And we often showcase these tools. I think Alex is going to talk about one that he mentioned at the last meeting. But we talk about these a lot, but there's a big hurdle towards going from a concept of an app to actually doing it, especially if you're not a big coder. And this really kind of does the work for you, at least getting you started with building an app. This is a generative AI tool, so it's one that is built on prompts. You ask it a question, it produces something, but it is a tool that is built around Shiny specifically, so trained around all the resources that are geared towards building Shiny apps and gives you an answer that is specific to Shiny. So I'm just going to show you an example. Build me an example dashboard with the Palmer Penguins data set. And so it goes through all the rigmarole of building the app. And what's cool about this is you get the code, but it actually will run the app in the browser itself, so you can see it in real time. So it's downloading the content, the dependencies, and then when it's ready to go, you have an app in 2 seconds. So this is, if you're not familiar with this, okay, it doesn't work all the time. But if you're not familiar with this data set, this is the Palmer Penguins data set. It was a replacement for the Iris data set that was used in many examples in historical R documentation. But it's basically a toy data set to sort of show you simple examples and kind of demonstrating principles around just exploratory data analysis. And this is a measurement of bill length and bill depth for 3 different species of penguins. So, you know, being this is, I didn't give it a whole lot of examples of, you know, in the prompt of what I wanted this app to do. It kind of just created some generic things. But you see you have full functionality minus whatever this was supposed to be. But you know, me as somebody who's been building Shiny for several years, just something like this, starting with code like this, would have taken me probably an hour to create. Just the basic structure of, you know, the UI component, what you see, and then the server component that actually handles the inputs and outputs. So this will get you started very quickly. Just for fun, I'm going to give it one more prompt. So this is another R package that creates a user interface with a different format. So this was using, the one it showed here was just the basic Shiny functionality to create the UI, basically a setup that works with baked in Shiny. Oh, it didn't work. But the BS lib package is one that I'm going to show you later that I've used for the FIB dashboard. It's sort of a different format to create a layout based on a JavaScript library. But you'll see, you know, it's not perfect. I'm doing this on the fly, but let's see where BS icon is. Let's see. So this is where you can troubleshoot it. It couldn't find the function BS icon, and we'll see if it fixes it for me. On awesome. So I was missing that dependency. So you can see how you can just sort of use this iteratively to troubleshoot and modify the output. And hopefully that works. Yeah, there we go. So it was missing this bit, but now we see we have a different dashboard, different sort of layout here. This still, you know, we're not working for some reason, but you know, again, this would take me a lot longer to do on my own. But now I have basically starting code if I wanted to use this for, you know, water quality dashboard. Anyway, I thought that was kind of a game changer when I saw that. If you're interested in dabbling with Shiny apps, it's a good place to start. You can feed it like, you know, an example of your data set you might want to play with, the first 6 rows and say, okay, now build this around this data structure and it'll do it for you. But yeah, I thought that was pretty cool. Okay, yeah, just last thing, upcoming schedule. I talked about Hack the Bay, which is happening next month. Please sign up if you have an interest. Or if you know others that might be interested. I also should mention you do not have to be a coder to come to this. We're looking for subject matter experts, as well as just sort of big picture thinkers about how these indicators could be reported. So that's, knowing how to code is not a prerequisite, especially if you're using something like this shiny dashboard. So yeah, our schedule for next year, I think there was an email that went out a week or 2 ago with our schedule for next year, the Open Science Subcommittee meetings. Next one will be May 28th. And then the final one of the year will be actually a year from today, exactly. So make sure you get those on your calendar. Okay. So that's all I have. Any questions, comments about any of that stuff before we pass it off to Jim?
Oh, Marcus, I'm just going to do a quick plug for
Oh, right.
our dashboard. So at the county, we've been developing a water quality dashboard, and we've recently got our red tide and coastal bacteria data on it. So it's gone through, like a review process. It's been going on for a while now, but I think it's finally at the point where we can get it out there to the public, and it's pretty close to being done. All right, I'd say it is done. So I'll put a link to that in the chat. If you want, just feel free to look around in it, see if everything works. And if you have any suggestions, if anything is broken, then please feel free to reach out to me and let me know your feedback.
Yeah, so Alex, you presented this, what's the last meeting or the one before that?
Yeah, the last one, May. Wait,
Yeah, as a
here it is.
preliminary. But now this is new and improved, finalized, finished. It's pretty slick. We were looking at it earlier before this call. So yeah,
Data.
here's recent red tide data.
Mhm.
Bacteria. Go swimming at the beach seems okay.
We can't tell you if it's safe or not, just what the value is.
That's the disclaimer.
Yeah.
But I can say go swimming because I didn't make the dashboard. I'm not
Okay.
responsible for it.
Exactly.
All right. Well, Jim, we'll pass it over to you. Let's see. Center.
So Alex, labeling the points green with the tag good doesn't mean that you're saying that it's safe?
That's a personal opinion.
Okay. Well, I'm about to have some personal opinions as well, as I will explain. So you're gonna share my slides, Marcus?
Are you able to share from the button on the bottom?
Yeah, hold on. Let's see, just want to make sure I do it the best way. I'm gonna do it this way.
I made you co-host. You should be able to share, no problem.
See, am I sharing or not yet? Oh, there we go. Second.
You're sharing something. Mine's picture.
Sharing the wrong screen. Let's see here. Why did it do that?
So while you get that set up, I'll just say that I did work, as Jim said, I worked with him for 4 years doing a postdoc at EPA, and I'd say he's responsible for indoctrinating me into the world of estuary and science. So I wouldn't be at the Tampa Bay program if it wasn't for the work that I did with Jim and Gulf Breeze at ORD. And I'm also responsible for indoctrinating him with open science. So you were a SAS user before I started, and I got him into R. And now I guess maybe we've gone full circle, and he's talking about open science now at ORD up in the Northeast. So really excited to hear what's been going on up there.
How does that look? Are you now looking at my slide?
Yep.
All right, I got it. So, this is great to be finally giving this talk. Marcus and I have talked a couple of times before about me sharing some perspectives on open science in the EPA or in the federal government. And this, as you might imagine, has created some controversy for me to deal with. And I think that I've found the secret formula that will allow me to talk about this, but I'll ordinarily I would let it go by without pointing it out. But at the bottom we have our standard disclaimer that says, I'm not speaking for the agency, and I think you'll understand that better by the end of my talk. But what I'm doing to, I guess, enable me to talk about it is to share not what I think should happen or what would be best if happened, but rather talk about my experiences specifically in trying to practice open science or in actually practicing open science in the context of a particular project, which in this case is my work for ORD, supporting a dissolved oxygen water quality criteria rulemaking, which is currently still in process. So I'll provide a little background on that as the time comes. So I have my hexagons too. I noticed that Marcus and I, maybe we can muse on this at some point, but like I don't know where these hexagons came from, and it's like a thing in open science, but I'm borrowing one from Julie Lowndes. The Office of Research and Development signed up with OpenScapes, the organization, to help some of us in ORD learn some skills in open science. And I participated a couple of times, mainly to help bring some teams that I was part of sort of into that framework. And so I looked to her paper for a definition of open science that I'll then kind of reference in terms of how EPA fits with that or not. And so this definition refers to being transparent at all stages of the research process. So that includes having free and unfettered access, ideally, to your data, your code, basically everything. And so keep this definition in mind. What Marcus asked me to talk about was how open science works in a federal agency, and specifically in the EPA. And I think a while back when I wanted to talk about this, it led to me not being allowed to give a presentation. So I've learned some lessons. And what's important is to narrow this down to something that's sort of in my lane, in my wheelhouse. So as I mentioned, I'm going to talk about how I used open science when I led ORD's support for this rulemaking on water quality criteria for the Delaware, and talk about how I used open science principles, how those were reflected in EPA's policy process, and then how and why the process followed or did not follow the definition that we just saw from Hampton et al. And then a little bit about the effect, or what I think was the effect of those differences. So to provide a little background, The Delaware River, which flows right through Philadelphia, a major urban city in the mid-Atlantic, has had low dissolved oxygen in that portion, in the portion of the river in Philadelphia, which is tidal fresh, has pretty much zero salinity but a 2-meter tide. And it's been a big city for a long time. Lots and lots of wastewater, both untreated and lately more treated, has flowed into the city or into the river. And back in the late 60s, there was some initial regulation of dissolved oxygen levels. And the EPA determined, and I've underlined determined for reasons that I'll explain in a minute, in December 2022, that those decades-old DO criteria needed to be changed under the Clean Water Act in order to protect the Atlantic sturgeon, which is also an endangered fish. So there's Endangered Species Act implications as well. A determination is actually something that the EPA has clarified in recent decades to be like a specific action, or essentially the EPA says something needs to be done here and provides the rationale. And so we wrote this determination and published it in December 2022. I was involved in that. And that determination set forth a timeline for the EPA or the states to develop dissolved oxygen criteria for this portion of the river. And so initially, it wasn't clear that EPA was going to be doing this at all. We were actually talking with the Delaware River Basin Commission and the states of Pennsylvania and New Jersey, especially. Basically, they might have proposed criteria and ultimately adopted them. In the end, they left that process to us, to the EPA. So in December of 2023, we proposed revised dissolved oxygen criteria. So the criteria proposal is part of the rulemaking process under the Administrative Procedures Act, which I'll talk about a little bit more later. So we're still in the process of promulgating or releasing the final rule, which again, underlined because these are things that are stipulated in law. The final rule will logically follow from what we put in the proposed rule and will reflect the agency's responses to the comments that we received from the public. So we received a lot of comments, thousands of comments after releasing the proposed criteria in December of 2023. So to get this back around to science, federal regulations require that water quality criteria are based on a sound scientific rationale. Those are the words in the regulation. And what that means is that the rationale is science as opposed to, say, an economic convenience or some other reason. And that it can be one of the three things listed here, either guidance, which EPA publishes recommended approaches for developing criteria. You could modify the guidance to reflect site-specific conditions, or then the catch-all other scientifically defensible methods. So essentially what that means is you can use anything that's scientific as long as it's defensible. That's what my experience with the process says. So the role of the Office of Research and Development within EPA, which is what I'm part of, and Mike on this call as well, is to provide scientific research and technical support. And the latter can mean that we're putting together scientific research that other people did, which we often do, to support the EPA regional offices, the program offices, or whatever stakeholders, which could be states or interstate commissions. In this case, the Delaware River Basin Commission is involved in taking the actions that they do. And one of the things that I think is important relative to open science is that the process of developing a regulation, in my experience, is a deliberative process. So we sort of start out with a question and some ideas about approaches, and that leads to some, well, we need this kind of calculation or this kind of analysis, and so you do it, and then people look at it and say, maybe we need something else. Can you do it this way? And then the need goes back to a new problem and a new thing that you need to do. And so over the past couple of years, I started off with, hey, can you join this conference call? And I joined the conference call, and then, hey, can you tell us what this paper means? And then maybe you can do a few analyses. And then next thing I know, I've got like 25 R programs and all this raw data, and I'm like, holy mackerel, how am I even gonna, keep all this stuff together? And so this again feeds into where I'm going on the open science. So to provide EPA with a sound scientific rationale, I did research and provided a bunch of these analyses in this sort of iterative manner for about 30 months. So I obtained all kinds of data from model results from local data collectors. I used existing models. Actually, the fish bioenergetics model that I started with was coded in SAS and then sort of semi-converted into R. And I finished the process and turned it into an R function. And this model that I developed creates a thing we call the habitat suitability index. So essentially, if you have a certain value of the habitat suitability index, then we call that habitat suitable for Atlantic sturgeon. And then the goal is to develop measures of dissolved oxygen status that can be associated with the habitat being suitable. So we devise a threshold for oxygen that leads to suitable habitat. And as I mentioned, some of these during this deliberative process, people would see what I said or see what I'm talking about and say, hey, what about this? Can you tell us on Thursday about it? So there's this process of being able to do science fast, share it mainly internally, which I'll get to in a little bit, and make presentations and not lose track of all the stuff you're doing. And these are some maps of habitat quality that I derived using this fish bioenergetics model in R, applied to water quality data generated by a EFTC WASP water quality simulation model for this stretch of the Delaware River. And what you're looking at in these two maps is the same stretch of river with the existing scenario, and then after they implement a bunch of procedures that are going to upgrade the wastewater treatment, so they discharge less ammonia and nitrogen, which leads to oxygen consumption in this stretch of the river. So how did my work follow open science principles? I had a couple of slides that sort of talked about open science, but I think you all know what some of the goals are, so I won't get into that, or I won't repeat that for you. But by wrangling the data and doing all the analysis in R, I was able to reproduce my own work for myself, change it and do it again, for example. And I'll get to it, other people were able to use it as well. One thing that was a requirement of our quality assurance plan that I developed for this project was I needed to have version control of the data and the code. GitHub took care of that for me. So I was the only person who was using my GitHub repository as I created it, but it was still great to do it that way and keep a record of what I did. The actual analysis ended up having a lot of layers and fairly complex. I distilled those things down into user-defined functions that I could put aside in a functions file and forget about how they worked and just use them, which enabled me to build more and more complexity without losing track of what I was doing. Having good comments and structured programs made it easier to follow. In the repositories, having variables defined and their units defined was useful. Ultimately, I needed to have all of the work that I did reviewed by two people internal to EPA who were supposed to run all of the code and show that it worked and ostensibly find errors, which, you know, is tough. If any of you have tried to review someone else's code, I think that's tough. But one thing that was possible was that I could just one after another run these R markdown scripts, and they didn't depend on the status of my environment or anything else. It was just like running it cold. And so my code reviewers were able to run the code. So those are open sciencey kinds of things in my view. And then importantly, and I'll comment on this a little bit as well later in the talk, the final code and the data were released to the public via a public GitHub repository, the existence of which we announced in the Federal Register when the rule was proposed. So there's sort of these federal communications channels, but then those were linked to GitHub and a public. This is the repository right here. Has all the folders just like Marcus taught me to do. You know, and this is open to the public. And the I put in the HTML files that are created when you knit the R markdown as well. So there's a couple things that were benefits in my perspective of working this way. The main beneficiary, I think, was myself. I absolutely would have just lost track of where my code was, what I did, where. I actually started, and I don't know if other people have done this or anything like this. I started making kind of like a Dewey Decimal System of R scripts that was hierarchical for the different aspects of the analysis. And then I used those numbering codes to link figures. So if I had a file that was created from a script, it would have a number that would tell me the script that created it, so I could go back and find it and change it and regenerate it, that kind of thing. Several times over the past 30 months, I've done other things for, you know, a month or two, sometimes longer on some things, and then it comes back around and they're like, hey, we want you to redo this thing in this other way that you haven't looked at in a while. And this is to borrow an OpenScapes term, or this is where I heard it anyway. I had to kind of onboard myself again, like remind myself of how I did it, get back into the code, and working in the way I did enabled me to do that without too much pain and agony. So I was able to modify, update, replicate the work when it was necessary to do that. The other beneficiary, or in terms of the process, and I mean this includes me as well, was that in order to follow EPA's review requirements, I had to get code reviewers, as I mentioned, to go through the code, run it, so forth. They were able to do that. They just cloned the repository, gave them access. They went through it and were able to follow what I did. And then ultimately, when the code was released to the public with the rulemaking, stakeholders outside of EPA were also able to use the code, which I'll mention at the end. They absolutely did do. So there were a few benefits of open science that weren't realized. Maybe they ultimately will be, but you know, one of the things we often talk about is the opportunities for collaboration. So the code was developed in a private repository within EPA, and that was not optional. I wasn't allowed to just open it up and let other people wade in and help me if they wanted to. And in fact, other people inside of EPA also didn't help. In this case, I wrote all the stuff myself. So the benefits of collaboration didn't apply in this case. Transparency, another benefit that's been cited for open science, was delayed. So, people, especially some of the state colleagues that we were working with, were eager to see how I was making the figures that I was showing them in some of the PowerPoint presentations. And they wanted code, and I was not allowed to give it to them. And I'll discuss that. But then ultimately the code was shared in completely, everything that went into the rule, all the code and all the data. And so then once we did that, they then did use it. So one of the benefits of open science then that was not realized was faster knowledge dissemination. I suppose that since it was ultimately shared, then that helps with getting the knowledge out, but it didn't happen, in the 30 months that I was working on it, everyone was just, it was a black box for people outside of EPA. So, this is where it gets kind of tricky in terms of how I talk about this. So, EPA has been very clear that it likes the idea of open science. The Office of Research and Development funded us to work with openscapes.org and the Challengers Program and Julia Lowndes, and they didn't do that because they don't want us to do open science. But then in the case of this project, we did not really implement the transparency at all stages idea. And I think that there are some valid reasons for this, and I'll allow that there may be people who disagree, but I'll explain what I think anyway are the reasons why it isn't necessarily bad the way EPA operates. So first of all, when the EPA communicates, or did in the case of our project, it was very intentional. We were very particular to try to ensure that everything we were saying was technically accurate, meaning we had people looking at it to help ensure that it was correct. It was checked to reflect EPA's policy intent, which means a lot of the documents that we send out don't just come from staff level, but are actually reviewed in a painstaking process all the way to the top. In some cases, even the administrator, in the case of the determination and the proposed rulemaking. And we also have legal review of a lot of the documents to ensure that the language we're using is correct and follows the right kind of form and structure or so forth that we need to be legally sound. So communications that are the agency's official position, so that where we say EPA believes instead of Jim Hagee believes, those kinds of communications often had high-level review, including the EPA administrator in some cases. So communicating carefully and accurately is important for any organization. But why might EPA be particularly careful about it? So one thing that has been my experience in many actions I've been involved in is that once we're doing things, everything that we do or almost do ends up making a headline somewhere. I collected a variety of articles that came out in the media from interest groups and organizations throughout the process of this rulemaking. Just a snapshot of this one, here. So there's a lot of people paying very close attention because what happens has consequences and affects interests that matter to people. Stakeholders who have an interest in what we're doing, let us know about this. They don't just sort of talk about it casually, but they form very carefully worded letters that are equally vetted through their lawyers and sent to us through official channels. So we are put on notice about what they think. And so, that's a way of saying, hey, we're paying close attention to what you're doing. And that tells us, hey, you better be intentional, careful, and so forth in how you share information back out so you don't misspeak. And then finally, stakeholders consistently pursued a legal strategy in their interactions with EPA. So that could mean maintaining Freedom of Information Act requests to access information that was subject to FOIA. That could mean, or did mean, lawsuits, petitions. So we are likely to finish this work under a consent decree. Responding to a lawsuit that said, hey, you guys, we know you're working on it, but you're too slow. That lawsuit has been filed. Yeah, let me talk about so the reasons like why we aren't just throwing information out there are related to this, and I'll come back to it in a little bit more. The other thing is that everything that we do is specified how we do it under the law, specifically under the Administrative Procedures Act. For EPA, we disclose the processes by which we're going to make a decision. Like we tell people in advance, this is what we're going to do. We describe the rationales behind the decisions, including the scientific rationale. We receive and respond to public comments. And all of this is designed to help the public understand and potentially participate in the actions that we're doing. The EPA is required to publish the proposed rule and all the documents associated with it in the rulemaking docket. And in this case, that included the code and the data, which we filed a document in the docket that said, hey, this stuff is in this GitHub repository. So that's how we did it that way. We switched on the public access within hours of when I was told that the rule was live in the Federal Register. And then, the Administrative Procedures Act requires that EPA accept public comments and then respond to all of the significant comments. So, number one, we don't take GitHub issues as a means of telling us what you think of how we're working. You can't call me or send me an email. Those are, all the comments go in through the specific channel that is created under the Administrative Procedures Act. So there's just like a little snapshot of it here. So the process that we follow, at least as I see it, is intended to increase fairness and equity in access to information. And this is one thing where I kind of went back and forth with some of my supervisors because I said that it does make it fair, and some people are like, well, how do you know it's fair? And I'll admit that there's almost certainly still unfairness. People with a lot of resources have different opportunities than people who don't have a lot of resources. But the process is designed, so put it this way, there were stakeholders who would, if given the opportunity, attend every single meeting that we ever had, download the data and the code, and start giving us feedback minute by minute. And then there are other stakeholders that certainly don't have the capacity to do that. So EPA had an organized way of sharing what we were doing. We made presentations so that people who were interested in our work could understand the direction that we were going, and we could be responsive to how they think about it. But we didn't just dump all of the code out there, because that would just could potentially create more opportunities for inequity in public engagement. So EPA has a scientific product clearance policy. Mike, being in ORD, is certainly familiar with this, and Marcus, having also been in ORD, is familiar. This process did not allow us to share data or code until it had been reviewed and approved. And so I talked a little bit about fairness. Trust and confidence is another thing. If EPA says something or provides information, and then we turn around a week later or a month later and we say, oops, that was wrong. Actually, it's this. And then we do that again. And if we do that enough times, we end up potentially with a chaotic information environment where people don't really know where information comes from, if it's accurate, so forth. And the goal of EPA, which is certainly an uphill struggle at times for all of us scientists, actually, is to maintain the public's trust and confidence in what we're doing. So speaking kind of deliberately and ensuring that you don't have to correct yourself too often is a priority. And then, as I mentioned, fairness. Different stakeholders have unequal resources. So having an orderly sharing of information during a particular period kind of gives everyone not the same opportunity, because some people, once they get the code, are going to have 20 people who can work on it for the next 60 days, and other people are going to have 2 people working on it for the next 60 days. But they all have 60 days, and they were all given the same information at the same time. That's the idea. So despite the temporary limits on how the information was shared, there were some benefits of open science in terms of not just myself. So once we shared the data, stakeholders cloned the code and data, cloned the repository, and they used our data and models in a couple of ways. So we received comments during the 60-day comment period where they said, we ran your model and we have a different idea about what the results mean, and it's this, and they showed it to us. So that's kind of cool, I think. It would have been nice to do that kind of interactively, but I can see some downsides in that as well. The other thing that that people have done, the Delaware River Basin Commission created an indicator based on the model that they can answer the question of, how is this year shaping up in terms of water quality supporting sturgeon in the Delaware River? And then the National Marine Fisheries Service is proposing to use the calculations that the code enable to determine a reasonable level of what they call exempted take under the Endangered Species Act. So the water quality criteria that we propose don't prevent sturgeon from ever being killed by dissolved oxygen. And so since they're an endangered species, they get a permit that says, okay, there's still going to be this amount of what they call take, and that level will be set based on this model that we got from you and pulled off the repository and so forth. That's a nice thing as well. These are the fish that we're talking about. They start out a lot smaller than this, but they get very large. So I'll end there.
All right. Thanks, Jim. That was really interesting. Does anybody have any questions?
question for Jim, because I've been through the same process Jim has. Where in ORD we provide technical support documentation, and so that's what Jim did with his GitHub repository for the rulemaking. But Jim, did the program office at least announce ahead of time that the data and the code and the modeling would be made available? Like people were aware it was going to come out, or was it always planned just to do it at the very end?
No, it was not only expected but required that I think I'm not exactly sure the basis for the requirement. Like we haven't always had computer code, so the idea that you will share the computer code seems to be something that must be written down somewhere, but it was clear to me well before I shared the code that I had to share the code. And so I set up the process. Two colleagues, Fernaz Nujavan and Jeff Hollister, did code reviews. So we had to review the code, and then it was basically released as a separate cleared product. Terms that you'll understand, Mike. And then so once the code was a cleared scientific product, then the way that we chose to share it was in a repository, which we opened up concurrently with the rule proposal.
But your stakeholders, like the folks at the Delaware River Basin Commission, they knew it was coming.
Yes.
Okay, that's all right. No, I'd like to know just sort of how far in advance people were expecting to see all this coming out, because you had quite the deliverables there.
Yeah, I think I mean, not only did they know in advance, but you know, they knew because they'd asked that I couldn't give it to them when I gave it to them, but I told them that when it would come out, not only would they have it, but that I would be able to at that point help them in whatever way, you know, to get familiar with it, to answer their questions about it. And it's actually kind of odd. There really weren't very many questions. Just sort of quietly things that were calculated using the code showed up in the comment period. So that was kind of interesting. I mean, one question that I have for you know, some of the other folks on here is that some of these prerogatives and challenges that EPA have seem to be likely to apply also if you're in state government or local government. We're not unique in this way. And I wonder if, you know, like I see a dashboard showing like almost real-time data. And I've talked about creating things like this, and you know, they're not very easy to get approved in EPA, although they do exist. Like we don't provide one example that I've actually used in the past year or so is wildfire smoke forecasts, and it doesn't do any good to give you a forecast 6 months after the forecast period. It needs to be kind of real time, or else it's useless. So, you know, do other people encounter the same kinds of challenges, prerogatives, so forth in their work? And how do you see it as different from what I described, if at all?
I'll speak for the estuary program. I think that we have a little more latitude, and we've obviously been pushing on these things. And I think that's things that Marcus and I feel really grateful, and part of why we're happy that we can be in this position. But there certainly is that same kind of pressure, especially when things are related to regulatory actions or things that might be susceptible to legal challenge. So I just thought a lot of the things that you kind of talked about were really interesting. Like right now, we're looking at reassessing the assimilative capacity of the old Tampa Bay segment, and part of that work might result in changing people's permitted nitrogen load allocations. And so the idea that, you know, I think we certainly espouse that the transparency and data sharing ought to enhance equity, but it's very clear that there's disparities in people's capacities to manipulate this information or comprehend this information, and that changes sort of the dynamic in terms of like how different people are working this collaborative process for their particular benefit or their perceived benefit. And so it's kind of important for us to understand that as well. And so I think we've also made some compromises in terms of, what information is very clearly out there, publicly accessible, what information is sort of out there, but you have to know how to find it to get it, or we're sort of, controlling that flow of that information until we're ready and we feel confident that it's ready to be sort of out there for everyone to see and use as appropriate. But I also think it's really like, as the person who ends up being sort of our voice in the public and in the press and with the decision makers, if we don't get on this, we stop making science at a pace that's relevant for the public. And that's a huge problem. People have these expectations and I think, have a desire to want to make evidence-based decisions. But if we're always, working on a 6-month or a year lag, and that's pretty speedy, if you think about it, for a lot of the science out there, that ain't it for regular people. And so they just kind of will make their own calculus. And so I don't know if I have a question, but I think we struggle with all of that too. And I thought this was a really interesting talk to kind of think about these things in tandem.
Yeah, thank you. I mean, when I think about the dynamics that you expect in open science, it's sort of like this, everybody building everybody else up kind of collaboration where you share information and then they provide you helpful feedback and then you use that helpful feedback and it goes like this. But what happens if they take your analysis and then issue a press release that the Tampa Bay Estuary Program is working on flawed assumptions and they shouldn't be believed, and that's the response to the information that you shared? Now you're kind of like, well, wait a second here, now we have to fight this out in the press. Those are the kinds of things that can happen. And I guess if we have an environment where people are assuming that everybody's doing their best and then we try to help each other out, then open science works better than if we're adversarial like that.
Yeah, it's sort of, are we collaborating in good faith or in bad faith, and knowing like which kind of partner you're working with changes how you share that information with them. And that's maybe not, it's certainly not equal. I don't know, it might be equitable.
Yeah, I think what Maya said captures where the estuary program sits with open science in terms of the, I guess, more latitude we might have and how we can share information. It's really more about operating in good faith in most situations. And my experience as an individual, as a researcher before I was, working on things that might have, ramifications in the regulatory sphere or management sphere, is that I want things to be open because I want people to look at them and see if there's a problem with what I've done. And, that's, to me, the essence of what open source is really all about. It's a collaborative workspace where a complete stranger on the other side of the world can see your code and say, hey, you're not doing this right. I'm going to post an issue on GitHub, or better yet, a pull request that will fix your code for you. And then just through the nature of sharing, you've got a better product of just opening up to the sort of the crowdsourcing approach of, let's look at this and hopefully someone will help improve it. But another thing I often like to make clear in these meetings and when I'm talking about open science is that depending on what you're working on, it's not always good to be open, or you might have restrictions on what you're doing. And that's very much the case with somebody like you, Jim, that's working with the EPA, where there's serious ramifications in the regulatory sphere of the work. And so it doesn't always behoove you to be open in the interest of what you're doing, but also who you represent at the institutional level. And there's very real practical limitations on how open science operates in the wild. And that's why I wanted you to to talk about this today, Jim. And I know you had to thread the needle in some ways and how you talked about this. And so I appreciate you doing that. But it does, it's a real example of how, some things work, some things don't. It's an idealized approach to how science can be done. And we have to sort of figure out and navigate how we actually use it in practice to benefit not just ourselves, but ultimately what we're trying to do as researchers. And I think I'm working towards a question maybe, but what was really interesting is when I was at EPA from 2013 to 2017, I think, the state of open science there was minimal. I was involved with the R user group at EPA, and they would have weekly or monthly meetings, and I swear the 4 years that I was there, they would have a discussion throughout that whole 4 year period of how do we even get like package updates on our computers to get IT clearance to do that. And that was a real hurdle because it was, at the time, I think perceived as just this sort of external software ecosystem that was alien and a potential, security risk. And now, it seems like they've gone much more past that in terms of how the institute or the agency has adopted open science. And now, GitHub it seems like a resource that's used, albeit, with some sort of workflow to make sure, things are released on GitHub in a staggered fashion depending on the product. But just, in your impression, Jim, am I sort of how off base or correct am I in saying that EPA does seem like embraced open science a lot more since the time that I've been there?
Yeah, I think you're absolutely right. There's not everything that I do is as controversial as a rulemaking. I mean, I do just sort of everyday science as well, and I can have collaborators who are not at EPA who can don't tell anyone, but like they can have a GitHub, they can be authorized users in my repository, which enables me to like share files with people who are not in EPA easily. This is really a step forward. It used to be, like you said, kind of pulling teeth just to get R on your computer. Now you just say, I want it, and they push it and it's there. Just like that. They do it for you. There's still a little bit like, we're always a bit like a version behind on RStudio or R because they want to make sure there's no Trojan horses of, security risks or something embedded in it. How they do that, I don't know, but we are attacked all the time. So it's a legitimate concern. And I've never had any problem being like, other than sort of annoying that RStudio is always telling me there's a newer version and do I want it and I can't. I haven't been held back by that in any way. So yeah, there's that. Now we also have enterprise, like an enterprise space in GitHub. So, nothing says we support it then better than, we pay for it and give you extra layers of, I can log in with my EPA, like single sign-on, sends me right into GitHub. That's like, could you even imagine that in 2014?
No, that was not even a concept when I was there. That's pretty cool.
Yeah, it's really, so that's great. So we can certainly do things, with any of the thousands of scientists internally quite easily. If we're collaborating on things that aren't, with people, we can share things with people externally who are collaborators. It's just when you take that extra step to saying, well, anyone who wants this can get it and give me some suggestions in real time. We're not there yet on that.
And I don't think they'll ever get there. Not for a lack of ability, but more just the restrictions of the nature of the work, and that that's a very real concern that you got to work around.
Marcus, I got a question for you. One thing that Jim raised, and EPA is still working through this, is sort of this code review. When you want someone else to take a look at this, get their comment on So at CBEP and at operations that often have, limited staff who can do open science, who's doing code review of your dashboards, or how do you get that done?
Nobody.
Okay, so we just trust Marcus.
Yeah, I'd like you to trust me, but I'll admit my code is not perfect. And I strive to have good code. I have a lot of mixed feelings about code review, and I did have a question about that because I've done code review for USGS, for example. I've done it for Journal of Open Source Software, and there's different levels at which the reviewer can dive into the code, and you might get, just like any regular review of a paper, you might get a totally like superficial review, or you might get somebody just really trying their hardest to figure out, is this code legit? Is it doing what it's trying to do? All that. Yeah, we are a limited staff. I'll say that much. Like as you know, and the ability to have code review is we just simply can't. I do agree it would make some of our products better, and I would like to encourage that more, but I just don't see that being a practical approach for what we do. It's more just, can we get the information out there using the best science, and hopefully how it's translated from the research to code to the product is done correctly. And we like to build the things off of sound science, and we oftentimes, and I don't have too much time to go over this, but the FIB dashboard that I'll show, there are some reports out there. There's some research going into it, but the product is not one that's necessarily built off of research papers. So a lot of times I'm extending an original method and applying it in a way that may or may not make sense. And that's, I'm bringing it to a group like this to hopefully sort of vet the product in a way that I can get that feedback, and someone could say, oh, it's garbage, or it's maybe I can look at your code, that sort of thing. So not really a satisfying answer, but it is something that I try to be mindful of.
Yeah, so if I can say one thing about this, when you review a scientific paper, you're not going to find every possible mistake that could be in it, that someone might have done something in the lab. Maybe you'll see it, maybe you won't. And the same goes for code. So after I had two of the relatively strong coders that we have in ORD, Jeff, Jeff, Marcus, they told me that what they thought. I had a few things that I did that were mainly stylistic about the code, but they didn't find any errors. And then a week or so later, I found an error. And I'm the most likely person to find the error because I know how everything's supposed to work, and I can look at something and I'm, better positioned than a reviewer to see it. And so what was important, and this is maybe related to open science, but it's really about reproducible research. I realized the implications of the error that I found quickly. I called Washington at like 9:30 at night, and they answered. My colleagues in Office of Water, and I said, oh my God, I found an error. I don't know what the implications of this are going to be for the results, but like we've been briefing numbers up to people, and so we developed a strategy for how we were going to deal with it. And that started with me rerunning everything with the code fixed, and coming up with all the new numbers. And then staff in Washington went through with a highlighter in Microsoft Word, highlighted every single number that might change. And then after I had everything rerun, we went and checked all the numbers. And of course, if we had like our whole thing being generated in our markdown or something, that wouldn't be necessary, but that didn't happen. But the part that is good that I want to point out is that I was able to redo everything that I'd spent months building in less than 24 hours. remake all the figures that looked imperceptibly different, even though many things were slightly different. It was like I'd included an extra month that was not supposed to be there in one of the calculations, and so it changed all these things just like tiny amounts. And one of the actual criteria values changed by a reportable amount. But you know, I was able to redo that, remake all the documents, and send it right back into the briefing sequence that we'd set up with no delay. And that's the value of doing things in a reproducible way instead of, you know, a bunch of Excel spreadsheets or something.
Yeah. Well, the danger of that, Jim, is they're now going to expect you to do things very, very quickly.
Yeah. Well,
but that's definitely one of, if not the most greatest values that I found of doing work this way, is that you can, the reproducibility aspect and the ability to just update things, especially if an example, you know, you find an error, you know, it's almost trivial to just change one line and hit the button and it goes. I think that's great. But yeah, we have about 6 minutes left, and I have 24 slides, which I'm not going to go through. I do, yeah. So Jim, again, appreciate you being here. I'm sure we'll regroup after this and talk shop or something. But I do want to, let's see, in the last couple of minutes, just show you folks what I have. So going back to just this, am I sharing the right screen? Yeah. So.
yeah.
Indicator gaps, as I talked about in the beginning, the hackathon, you know, ways to kind of round that out. Fecal indicator bacteria is something that's in our CCMP, been there for probably ever since the CCMP has been a thing. We haven't really had a good workflow for reporting on FIB in the Bay at a large scale. And this is a case where we have good data. We more or less have a method, but it hasn't been operationalized. And so I've been kind of working on this over the last year or so. Recently in the last year, I've contracted with Catbird Stats with Kim Cressman. She helped flesh out a lot of this work in terms of operationalizing it. But I wanted to show y'all what I have just to get initial feedback. Again, also going back to that idea of this is a new product, and it's probably, I guarantee you it's not perfect in terms of what it's displaying, because it is built off of something that is more precise in scope in terms of spatial context and temporal context. So just the, let's see. So the existing products that are out there already is, so the Hillsborough River and Alafia River Basin, as well as Manatee County, there are BMAPs in place, Basin Management Action Plans to address TMDLs for fecal impairments. And these have been in place for a long time. And because of that, there are already some existing products that have been produced to support management efforts to restore some of those conditions. And this is just a screenshot from a report card that I think actually Ed had put together many years ago, that actually does create this report card for multiple stations in the Hillsborough River Basin. I think there's a similar thing for the Alafia, but you can see this, you know, this is quickly just showing you status and trends based on some of the FIB data in this watershed. And so this, as you can see, stops at 2012, and this was probably something that was, well, definitely something not created and a workflow that is easily reproducible. So I took it upon myself to try to create this workflow in R, taking the input data, creating the output, and also kind of expanding that to some other products too that EPC has created. And I know they produce these monthly maps on a regular basis that they report at the BMAP meetings. This is just showing you cell concentration levels of Enterococci and E. coli for different stations in the Hillsborough River and Alafia River basins. for a given month. And I saw Dave Carlin was on the call. He makes these maps. I don't know where he's gone, but I thought it'd be great if we could, again, operationalize this. So I kind of did my whole open science workflow to do this. Before I show you the dashboard, I want to just first explain what this is not, because I think it's important to make that distinction that this is not a replacement for beach monitoring programs. Those have a very specific purpose, and this is not meant to support that, because those are very site specific. And I'm trying to look at a bigger picture of what's going on in the Bay as a whole. And this is also not a tool for source tracking, although it could be used to support that. There are other methods like MST work that some of our colleagues at USF are working on, as well as others that speak more directly to that. But this is more, again, just a tool to, I think, look at this at a bigger picture and more broadly to support some of this BMAP TMDL work that's going on in a way to create more timely and more up-to-date products. So all of this is in TBAP tools. So if you have an interest in getting your hands on the code to create some of these graphics, it is in TBEP tools. But I'm going to show you the dashboard, and this is proof of concept at this point. This is a lot like our existing dashboards. There's multiple tabs. There's hopefully sufficient documentation to tell you what's happening. There's data downloads, and then there's different places where you can look at different data sets. And so first I'll show you this Bay-wide component, and this is built off of, again, the methods that are in that two-pager report that Ed put together many years ago. I've essentially, and this is kind of where I'm opening this up to critique, is we've kind of chosen these stations as sort of terminal nodes or terminal endpoints where rivers or tributaries are entering the bay, and there's a sufficient long-term record of data. You'll see that's not the case in some places like the Manatee River or Boca Ciega Bay, but for the most part, the stations around the four major bay segments have enough coverage, and I think they're descriptive of fecal potential load entering these bay segments. But the problem I have with this is that, we can display Old Tampa Bay as having an overall score based on what the categories are for the stations entering the bay, but this is not an accurate depiction of recreational risk or exposure risk in Old Tampa Bay. In my opinion, this is basically saying, if somebody from the public were to look at this dashboard, they would think that Old Tampa Bay is riddled with fecal pathogens because the whole thing is red, doesn't look good. And that's not the message I want to portray. But I do want to have a tool that does somehow describe the state of fecal loads at a bay segment scale. So I'm just going to throw that out there. This is a problem I've been struggling with, how to display this in a way that's true to the actual data, that doesn't paint a picture that's alarming or not displaying the results in a true fashion. I have a tab for EPC data, so that's the other thing. I've kind of sort of spread this out to different monitoring programs. The Bay-wide tab is an agglomeration of different monitoring data, but Hillsborough County's here, Manatee County is here. Greg, you might have interest in this. We have, for each of these three tabs, we have an overall report card that has that A through E category, as well as the ability to drill down by year and month. So now we're looking at monthly level samples from which the report card is derived. And you can also click on each station and get a time series of all the data at that station, which I think is pretty cool. Just to sort of a coding geeking out thing here, this is built on that BS lib package that I showed in the beginning, which is a different package for building a front end on the dashboard that has a little more, I think, useful interactivity than some of the Flex dashboards that we've created in the past. So you can, for example, expand these things right here and see it this way, which I think is pretty cool. I haven't been able to do that in the past with Flex Dashboard. I also had this custom CSS code that lets me slide the windows. I used the Shiny AI tool to help me figure that out. I've never seen that applied in any dashboards built in Shiny before. Seems silly, but I think it's a really useful way to sort of interact with the plots in a dynamic way. So this is, yeah, again, I didn't have enough time to go through all of it, but this is something we've been working on over the last year or two. It's kind of at a stage where I'm hoping to get feedback. Greg, I'd love to hear if you have any thoughts on this. But yeah, that's pretty much where we're at with this, hoping to improve it. And at some point we'll maybe have a 2-pager PDF, or this will have a home on our website. So that's what I got.
All right. Does anybody else have anything to bring up? I know we're at the end of the meeting. 4 minutes past, but nobody else has anything. Then again, the next dates are May 28th and December 10th. So hope you all have a great holiday weeks for the next couple weeks ahead. So see you in the new year.
All right. Sign up for the hackathon, please. Thanks all. And thanks, Jim, again. We'll be in touch.
Thanks for the opportunity.